Hello, so today I wanted to go back into two-pointers because I'm trying to get back into lead coding a little bit more after the projects I was working on. And two-pointers is a very easy concept to grasp, but then it opens the door for very convenient solutions and ways to do things in a very easy way. So I wanted to go into how to identify a case scenario where you can use two-pointers and different ways that it could be implemented. And I'm just going to solve one leetcode problem I was on yesterday using two-pointers. So obviously two-pointers, just like the name indicates, is the fact of using two different pointers in your list or array or whatever data structure to identify something, right? So let's say that you have an array like so, trying to stay in my screen here, and you have many elements until the nth element, okay? And you have a value x that you want to find out that is here, 0th element. So what you might want to do is just like iterate through everything, right? Like just go like from 0, if 0 equal x, then return index. If index 1 equal x, then return, etc. And then here it means that your big O notation for your algorithm might be n simply because you're just going to iterate once and do a simple check on every value. But this, even if it's linear, it can get very long and complicated for an operation that's pretty basic, right? Just finding one value. So what you can do with two pointers is just say, I'm going to start here and here at the nth argument, and with every iteration of my loop, well, I'm going to do one movement here and one movement there, meaning that each pointer is going to have n over 2 values to check out, and in this instance, this pointer is going to do just 1, 2, and 3 iterations until it finds out your x. When with our first method, maybe there was here like 200 values to check out, and so you wouldn't be able to find it out in a faster way. So this is why two pointers can be very useful, but it's also useful in other scenarios. So for example, let's say that you want to reverse an array in place, and that's something that is very appreciated, usually doing things in place, because you don't use more space, you don't create a duplicate list, and it can save a lot of memory and space when you have bigger data sets. So let's say that you are here and you want to reverse the array. Okay, so you're here with your stuff and you have like here it finishes with 7, and here with 6, and here you're gonna have something like 3 and 2, 1, 0, and 10. Well, to reverse the array, you could just create another one and then like just say like iterate backwards, okay, and then put it in the new array that would be here, and just do this. But this is not efficient for your space, your space efficiency, right? So what you want to do is use two pointers, because basically reversing an array is just like taking this value, and switching them together. And then you're gonna have your next step where you are like this with 7, 6, and everything else being the same. So your pointer is now going to be at 10 and 2, same thing, you switch, and so you have 2 and 10, etc., etc., until you reach the same value, which means that it's either a pair amount of values, and so usually it means that you're going to just finish by switching the two last values, or it's an odd amount of values and the middle one is not going to move. So yeah, just reversing in place is a very, very good idea with two pointers. And finally, one that I haven't done myself, but it's pretty interesting, if your array is sorted in a non-decreasing order, so everything is just increasing all the time. And for example, that's another exercise that I checked out, but we're not going to do it today. So let's say you have this, and you want to put every value in your array to the square of the value, and order it in a non-decreasing order too. So you would have -2, 0, 1, 3, and let's say 10. Here, if you just do if you square every value in there, this is gonna become 16, this is gonna become 4, and so it's gonna be more than 1 squared or 3 squared, right? So with 2 pointers, you're able to do it like so. First pointer here, second pointer there, and what you're gonna do is just say, well, this is gonna be squared, so 20, this is gonna be squared, so 16. If this one is bigger than this one, then you're gonna keep it in place, okay? But if this one is bigger, then it's going to take the place of this one, and the next and this is staying in the queue. So here, what's happening is that you're placing your 20, your 100. Sorry, what the hell am I doing? So yeah, you're placing your 100 here, and your 16 there. So your 16 is just still in your pointer, right? So this is going to go there now. 3 squared is going to be 9. So what is this going to do? Well, 9 is smaller than 16, so boom, this is going to be 16 and 9 is going to be remaining in the pointer, okay? And so by doing this, you are going with every step, so then going here, okay, you're going to have -2 squared, which is going to be equal to 4. 4 being smaller than 9, you're going to place 9, and so you can finish with this, etc., etc. So 2 pointers is very practical for this kind of stuff, and many more that I'm not going to detail too much because obviously I am learning too, and those are the core concepts I have already applied and understood a little bit better. And so here we are on our LeetCode problem. So what we're going to do is the 2-sum number 2 problem, exercise number 167, which is pretty easy. It's just like given an array of integers, so numbers already sorted in a non-decreasing order. You need to find 2 numbers such that they add up to a specific target number, which is given in your function. Be careful, what you have to give back in the end is an array, okay, an array of the 2 indices of your answer, so indices index n and index m, like so. And the 2 numbers must be 1 indexed, okay, so it means that you won't use indices like so, like 0, 1, 2, 3, but you're going to start at 1. Small detail, but you could lose some time doing this. Okay, so this is not that hard. What are we going to do this? So you have examples here, so just an input of 2, 7, 11, and 15. If your target is 9, then obviously the answer is index 1 and index 2. It's 2 plus 7 being equal to 9. Why are we using 2 pointers into this? Well, there is one thing that you can do with this exercise is first get rid of as many useless informations as possible. So let's go more into our exercise plus but here, because in here what's going to happen is that you obviously have this array that starts at the 0 index and ends at the nth index, and since you're searching for something equal to your target and the array is in non-decreasing order, it means that any number that you add to the first number of your array here is gonna have to be smaller than the target, right? So what do I mean with that? If this is 100, and if your target is 7, then anything that's bigger than 7 is not of any use for you. So what you're going to do is put a first pointer here and iterate through it backwards until you find something that's equal to 7 or less here. But why stop there? Because obviously you need the sum of two numbers. So if your first value in your index, this first value, like we said, in a non-decreasing order array, well, is going to always be the smaller value of your array, then it means that your actual value here plus the first value of the array must be equal or smaller than your target value, right? So here, if your target is 7, okay, but your first value in here is not 0, it's 3, well, it means that you can keep on going because 7 is still too high, right? 7 plus 3 is more than the target. So it means that maybe you're going to go through 6, go through 5, just not care about them, and then you're going to reach a value that's like, I don't know, 4, and here, boom, you have your solution, right? And if it wasn't a solution, well, it means that you need to start doing what? Well, move your first pointer here to the right until you find out each other. Okay, so let's start with the coding bit. We said that we needed here 2 pointers. So first pointer, I'm going to call it x1, and it's going to be equal to 0 because 0 is the first value of the index. And I'm going to have x2, which is going to be equal to the last value, the last index of the array. So it's going to be length of numbers. But remember, because we start at the 0 index, we have to remove 1. Okay, now I have my 2 pointers, one at the beginning, one at the end. Now what I want to do is just basically get rid of every value that's too high to be even considered. So I'm going to be like if, we're going to see that later on. First I'm going to do my loop. So while x1 smaller than x2. So this while x1 is smaller than x2 is usually how you're going to use your 2 pointers system, because usually you're going to have 2 pointers that are going to go towards each other from different spots of the array. So that means that when they meet each other, well, it's over. So you always have to stop it just before that. So if in the next iteration of your loop x1 is going to be equal to x2, then you should be stopping whatever you're doing and returning some kind of value or error if you need to. And now, well, we're going to do our first test, and let's make it easy by just checking out if we found our value. So we're going to be like if numbers of x1, plus numbers of x2 equal target. Then we're going to return our answer. What is our answer? Well, it's going to be x1, our index, plus 1. Remember that we are using a 1 indexed answer. And the second value is going to be x2, same thing, plus 1. Okay. So this is best case scenario, like x1 and x2 just found the good target values, so that the values at index x1 and index x2 summed together are the target number. But obviously this is not going to be the case most of the time. Most of the time what we're going to do is move those 2 pointers. Okay, and the first thing we want to do is move the second pointer to the left until we reach values that are lower than the target. So we're going to say elif, okay, numbers x1 plus numbers x2 is more than target. Because remember, we had 2 case scenarios, and obviously if x1 at the index 0 plus whatever place we are at is more than target, then it means that those numbers can never be taken into account in the search, okay? And so here what we're going to do is simply, well, decrease the value of x2. And so during our loop, we're going to be like, well, if we don't have the solution, well, we're going to move x2 to the left, and so we have a value that we can start actually using for our calculations. And then maybe we reach a spot where x1, the values at x1 and x2 added are smaller than the target, but we still haven't found the good two indices. Then maybe at that point we want to move x1. So here, else, we're going to increment x with 1. And we basically have it, because what's going to happen is that even if you reach a point where you have a target of 10 and here your value is 2 and here your value is 6, well, obviously you're good, right? Your x2 is okay here because 6 plus 2 equal 8 and it's not bigger than 10. And so maybe you're going to move to your 3 here. So x1 is now going to be here, and so you're going to be, well, my solution is 9, so I have to move. But maybe this is 5, okay? Let me clear that up. Maybe it goes from 2 to actually being 5. And if this is 5, it means that here x2 is now too big. So you can get rid of it and maybe go to the next thing. But here it would be another 5, for example. And maybe you would have that. You would have an x1 at the index 1 plus 5 at the index 3, for example, which is equal to 10. Maybe those are just 5s, you know. Okay. So what's going to happen is that this is always going to be like moving either one pointer or the other until you find your value. I also want to add one last thing, because I realized that a lot of the times you came across solutions where the index, the first array, the numbers array, is just two values, double 0, minus 1 and 0, 1 and 2. And I mean, you're going to save yourself a lot of work if you just go if length of numbers equal 2, well then return index 1 and 2, because the exercise tells us there's always an answer and you're always gonna have at least two values. Like, you don't have wrong entries in this exercise, and so it means that if you have an array of just two values, those two values are the answer, and it makes your algorithm overall a little bit faster, because whatever happens, this is gonna be just 1. Like for your big O notation, this is 1 1 1 1 test, and this is a while, which is gonna be technically n over 2, at worst n. But there's no case scenario where this is true, unless your x2 pointer maybe does the whole thing by itself, but I didn't really give a lot of research into that. So for me, the big O notation here is always going to be O of n, or O of n over 2. So that's an exercise for another day. Big O notation is sometimes complicated for me. Okay, so let's submit this. And it's accepted. So let's go there. Obviously I tested it out, I found it out the other day, and we have an answer of this. So a little faster than the previous iterations. I've been testing out some different stuff. I had a more complicated algorithm to begin with, and then I tried to make it cleaner, and that's what I came across. Obviously you could have way more efficient ways, smarter Pythonic way of doing things. This is just my basic two pointers approach, and I hope it was clear and easy to understand, and I'll see you next time. Keep on coding.